Hi, welcome to Learn Maths Today. The next topic is trigonometry, so let's break down some concepts step by step and make it easier to understand. Okay, so first I'm going to go through a brief review of all of the types of triangles and their significance to trigonometry, because it's important to know these differences since some triangles can and can't be used with some rules. My best example of this would be the right triangle, because it's the only triangle that you can use sine and cosine and tangent ratios with to calculate side length and theta angle, meaning that none of these other triangles, if you see them, can you use the SOHCAHTOA equations that I'll give you soon. There are also other rules like sine and cosine laws, which allow you to use the more obscure triangles, but I'll get into that later. Right now, I want to look at basic trigonometry and emphasize that right triangles are the most important. So for trigonometry, again, the most important triangle for basic trig is the right triangle. And there are many different parts to this triangle that are configured around the angle theta, which is right here. And so I'm going to take you through them, and you have to make sure that you memorize these because they get really important later on in trigonometry. So the very first side is the hypotenuse of a triangle, which is always going to be the longest side of a triangle. Next is the adjacent angle. The adjacent angle is the side which forms the angle with the hypotenuse, so right here. And then finally, the opposite side is essentially the side length farthest away from theta. And then this next part is pretty important because it's going to inform your understanding of sine, cosine, and tangent, but it's not necessarily super important for you to know right now, but it is something that we're going to look at later and that you should memorize over time. So there is a special type of triangle that's known as a 30, 60, 90 triangle, where the triangle has angles of only 30, 60, and 90, where theta could be 60 or 30. This triangle has special ratios between sides. So in a 30, 60, 90 triangle, the adjacent side is equivalent to x, and then the hypotenuse is equivalent to 2x, and then the opposite is equivalent to 3, or is equivalent to x root 3. And these ratios will maintain consistent across all 30, 60, 90 triangles, no matter what x is, which also means that sine, cosine, and tangent of these 30, 60, 90 triangles will all be the same. Okay, so this is not exactly relevant right now, but you'll see later on why it's important that you know 30, 60, 90 triangle rules. And then it's also to just memorize these important terms in general, including like hypotenuse, opposite, and adjacent, because many equations in trigonometry are fundamentally based on the ratios that come from these side lengths. Okay, now I'm going to move on to explaining Pythagoras' theorem, which is important because it connects the lengths of the sides in a right triangle, allows us to find the value of any side if we know two of the other ones. In simpler terms, meaning if we knew C and we knew B, we could calculate A pretty easily using Pythagoras' theorem. And to kind of just define it out loud, Pythagoras' theorem is the square of the adjacent plus the square of the opposite equals the square of the hypotenuse. And very simple trig equations, like the example down here that I've displayed, will really just give you two values and ask you to find a side length using the equation. So that's what we're going to look at for the next couple of questions. Okay, I'm now going to ask you to solve these two practice questions to test your knowledge using Pythagoras' theorem. I provided an example on the previous slide, as you saw, where I used the equation, so hopefully you can use that to help you determine the steps you need to take, but it's pretty self-explanatory. I would just read the question, understand what it's asking and what values you're being given, and then try to solve it from there. Okay, so I hope the questions were relatively easy. Here I've provided the answers, and I'm going to walk through them now to help you solidify your understanding. So for question 1, which is this right here, we were asked to look at finding the hypotenuse of the triangle formed by a ladder leaning against the wall. And the hypotenuse, we know, is this long length because it's the longest side of this triangle formed against the wall. And then we were also given the information that the adjacent side is 6 feet and the height is 8 feet. So now we have our two values that we're going to use to calculate the hypotenuse. Then the next thing I would go about it is I would plug in 8 and 6 to their respective places in Pythagoras' theorem, and then I would set that equal to c squared, which in this case is the hypotenuse squared. Then I would do the squares and add the numbers up so that I can take the root of this number. So in case you just need help getting from c squared to c, what you would do is you would take the root of c squared, and then whatever you do on one side, you gotta do to the other, which would inevitably give you the root of 100, which is equal to 10. So therefore, c is equal to 10. Okay, similar to the last question, question 2 is also just asking us to use Pythagorean theorem to find the length of a hypotenuse. However, this question did have a higher level of difficulty due to the change in the units, which was required to solve the Pythagoras theorem. If you notice in the question, I phrased it as 0.1 kilometers for the adjacent side, but then 240 meters for the opposite side, meaning you need to convert either the kilometers into meters or the meters into kilometers so that you're able to calculate using Pythagoras theorem correctly. Otherwise, you would get a really obscure, incorrect value. So upon considering that and knowing that, I converted my kilometers into meters, and then I plugged them into the equation just as I did before. And figured it out using the same way. And I'm not forgetting that I have to take the root of 67,600 to find the value of C, which would ultimately be 260. And so that would be your answer for question 2. Okay, so in conclusion for this section, it's most worthy to know that this form of Pythagorean theorem only really works with right triangles. So that's something to make sure you remember when you're doing math, any math with triangles. And then additionally, it's used to calculate side length only. That's the only thing it can really help you determine. And then also make sure your units are consistent. And then this is the general formula that you have to remember and use. And then also, along with these other important details, you can use any combination of two sides to calculate your target side. It doesn't have to just be the opposite and adjacent, as long as it's two sides. You can use the hypotenuse and the adjacent. You can use the hypotenuse and the opposite, as long as you have two of the sides known with known values.